Welcome to Mastering Solutions. I've drawn our picture of what we have, and this is our converging mirror, and this is the focal length. And the light bulb, the object in this case, is located 3 times the focal length, so I drew it out here. Now we need to use ray tracing to solve for this, and remember, with any ray tracing question, always remember the 3 things, and hopefully you know them by now, but that is parallel to the focal point, and then the center of the lens, or the center of the mirror in this case, and then focal point to parallel. If you remember this, it'll get you through any ray tracing question. And so let's start first with a parallel to the focal point. So we're going to have collimated or parallel light coming from the light bulb here, and then it's going to reflect. And since it's parallel or collimated, by definition, it'll go straight through the focal point. Now we need to do the center of the mirror. And with the center of the mirror, remember that we're going to have the exact same angle because it's reflection. And so the angle of incidence will be the exact same as the angle of reflection. So that looks pretty close, but that's good. And so the last one, we're going to go through the focal point, and then we'll get parallel light from that. So we're going to go straight through the focal point. There we are. And then we'll get parallel light, and then we'll get parallel light reflected away. So now where they converge is pretty close. I was having trouble with this parallel one. It didn't want to cooperate, but we're going to see, of course, the image will be formed right here. It's inverted, so that means we have a real image. So we have an inverted and a real image. And now they don't ask us to calculate the distance, but it's good practice. So I'm going to do that as we've done in the previous questions. So to find the image distance, we're going to use the thin lens equation. So we have 1 over the focal length is equal to 1 over the image distance plus 1 over the object distance. We want the image distance, obviously, so we'll minus over the object distance. So 1 over s prime is equal to 1 over f minus 1 over s. And so now we can plug everything in. So 1 over the image distance is equal to 1 over the focal length, which we said is 20 centimeters or 0.2 meters. In this equation, it does need to be in meters to give you the correct answer. Otherwise, it won't be correct. Diopters is inverse meters. And then we're going to minus 1 over the object distance, which is 60 centimeters. And that's a positive 0.6 meters. Here's 1 over 0.2 minus 1 over 0.6, which gives us 3.33, and that's diopters. 3.33 diopters. So that's the power of the mirror. And then we want to take the inverse of that to give us the distance. So we have 0.3. So s prime, or the image distance, is equal to 30 centimeters for where our image is going to form.